If I want to teach you a concept from physics, such as the movement of a pendulum, I should just be able to draw the pendulum in the air between us. I should also be able to draw a graph which shows what happens when I apply an impetus to the bob of the pendulum, and then you can see the roughly sinusoidal wave which ensues as a result. If I want to teach you about an animated character, I should be able to draw a very fat character, or I should be able to draw the same character as very skinny. And you should be able to see, based on this, how the character movement is affected by its shape. If I want to teach you about three-dimensional rotation, I should be able to draw an object and apply various properties to that object, for example, color, and then drop that object into a coordinate system, which could either be a two-dimensional coordinate system or it could be a three-dimensional coordinate system. If we drop the object into the coordinate system, you can see that any changes to the object itself are reflected in the view of the object in the coordinate system. To do something a little more sophisticated, we need more sophisticated tools. For example, a 4x4 matrix, which can be used to affect translation or rotation. Now, this is just a symbolic matrix, but if instead I make a numeric matrix by, for example, attaching a slider to it, then I should be able to change numeric values in ranges, in this case, from 0 to 1 radian, or in this case, from 0 to 10 radians. Applying this matrix to the relationship between the polygon and the coordinate system, I should be able to now see how, by interposing the matrix, I'm able to change the rotation about, for example, the x-axis, or perhaps the y-axis. Notice that this is a slightly different matrix. Or I should be able to add time as a quality in this relationship by dragging time between the slider and the matrix itself. Now this becomes a rate controller. And I can, for example, rotate more quickly about the y-axis, or I could alternatively rotate about the z-axis. Now, everything I'm doing is actually three-dimensional. You can see that I'm actually rotating in 3 dimensions, and this is actually a scene that's floating in space between you and me. Now let's talk about dimensions. We can have 3-dimensional objects, but we can also have 4-dimensional objects. Here, for example, is a hypercube. Now, a hypercube, when projected down to 3 dimensions, appears to be the same as a cube, but if we rotate it about the right axis, we can see it's actually a 4-dimensional object that can appear through augmented reality to be floating in the air between us. Thank you.